Okay, so today we are going to talk about the difference between an observational study and an experiment. So both of these are ways to collect data. They both have their advantages and disadvantages, and they are commonly used. Okay, so an observational study is something where you only observe something and measure it. Okay, so there is no modification of the study's subjects. Now, the advantage of this is that typically in these situations, the subjects themselves may be unaware that they are being observed. This tends to be something that science participates in quite a bit, either with people or animals or physical systems, the universe. We watch it, we observe it, we don't change it, but we take measurements. So like if you're looking through a telescope and you're tracking the path of stars and their velocity, that's an observational study. Or if when you are, like, you might actually stand where we do check-in in Marshall Offutt and watch students come by and count the number who are completely in the dress code, who are partially in the dress code, and who have made no attempt at the dress code. But you don't impact them in any way, shape, or form. That's an observational study. Now, in an experiment, there's a treatment. And you usually apply the treatment to one group of the subjects. So those are what we tend to call an experimental group. So we tend to apply the treatment to an experimental group. Oftentimes there is a control group. Okay. Doesn't always have to be a control group in an experiment, but oftentimes there is one. And that would give us something to compare the experimental group to. Sometimes we do like before and after, so we could see like what was the group like before the treatment, after the treatment, this kind of thing. The upside of this is that we can control who's in the experiment and what else might be affecting the experiment. So let's say I want to test the effects of some sort of medication. Well, I may control both the experimental group and the control group and have them do exactly everything the same except for taking that medication. Even down to the point where I may give a placebo, so a pill that looks exactly like the pill that I'm giving the experimental group, to the control group, so they even go down to the level of having taken a pill to make sure that there isn't what we call the placebo effect, which means like you believe there was an effect, but it had nothing to do with the medication itself. Like sometimes people will indicate that they feel healthier simply because they've taken a pill, but the pill may be completely inert and not active. So in an experiment, you have a lot of control. You can control who's in the subject or who's in the test. You can control how they're treated. You can control for things like the placebo effect. There's a lot of options to control here. The downside is that people who are in an experiment know they're in an experiment. Okay, so whereas in an observational study, you may only have people who are completely unaware that they're being measured, or objects or animals, in an experiment, the experiment itself, because a treatment is being applied, it's hard to miss that you're involved in one. Okay, so where does the experiment get the advantage? Like, you have the advantage with the controls, right? You also have an advantage in that you can control against placebo. You have an advantage with the observational study because of the unawareness of and blinding of the participants. They don't know, they're blind to the study. Now, this has something to do with also lurking variables. Okay, so we're talking about what are called lurking variables. So the example that is oftentimes cited for this is that there is correlation between drowning rates and rates at which ice cream is purchased. So it is positively correlated, meaning that if drowning rates go up, ice cream rates also seem to go up. If drowning rates go down, ice cream rates also, purchase rates also seem to go down. And this correlation is really difficult to try to explain. And these things like happen like all the time, okay? But where you see two things that seem to be unrelated, but they seem to be having some sort of correlation. All right, so this oftentimes, like, there's a statistical significance here. We'd like to prevent drownings, so there may be a practical significance here, because, you know, if there's an implication that eating ice cream causes drowning, then we want to know this, okay? In reality, this situation is probably caused by a lurking variable. Lurking behind the scene is, in this case, the outdoor temperature. Okay, so why would that impact this? Because if the outdoor temperature goes up, the number of people swimming also goes up, which means there are more people who are risking drowning, so that would go up. Likewise, as the temperature goes up, it is likely that more people will buy ice cream because it's hot, and ice cream is something that's cold, and you like to have cold things on a hot day. So the temperature going up could cause both a spike in ice cream sales and a spike in drowning because more people are swimming. So the lurking variable here would be the outdoor temperature. Now, when you have an observational study, you would observe more drownings, more ice cream. That's it. But if you did an experiment, you could actually do something like take a group of subjects, feed them ice cream, and then go watch them swim. You can take another group of subjects and don't feed them ice cream. So sad, right? And then go watch them swim and see, hey, are people like less safe when they swim or more likely to drown because they ate ice cream? There, an experiment can control every other factor except for the ice cream. And in that case, things like outdoor temperature would be controlled, and we'd ultimately say, hey, yes, there is correlation between these two things, but definitely not causation, because when I control everything else, the correlation seems to go away. But if I don't control for outdoor temperature and then observe what's going on, I can see that the outdoor temperature is a lurking variable. Okay, so that's a lot. We'll revisit this more as we're going through the course, but there's something to think about. Okay, so let's recap. Observational studies have only observations and measurements and have the advantage of blinding, that the participants blinding, that the participants are unaware that they're being observed in most cases. Okay, in an experiment, we are applying a treatment to some people and then observing and measuring. And it doesn't have to be people. It could be animals. It could be situations. But we were applying a treatment. We're observing and measuring. And here you have the advantage of control, because you can control out other variables. So here, downside is that people are aware. You lose the blinding, because if you're applying a treatment, people know that you're applying the treatment. Here, the downside is you lose control. So depending on what you're trying to test, one of these may be better than the other in your design. All right, so there's observational studies versus experiments.